Hello and welcome to lesson 3-6, Solving Compound Inequalities, day 1. That's right, my friends. There is enough information packed into this lesson that we are dividing it into 2 days. I'm trying to get this done a little bit earlier in the day so I don't have my mental lapses like I did yesterday for the video. And hopefully I'm a lot more wide awake for this, for you. Could be bad for you, I don't know. All right, first of all, we're talking now about, we've talked about inequalities, just in general, inequalities, and the greater than, the less than, greater than, equal to, less than, or equal to symbols. We've talked about how do we solve them, how do we graph them. Today we are introducing compound inequalities. So immediately you should begin to think, okay, that's not just one, that's going to be more than one piece here. So a compound inequality that contains the word and we're going to pause. Clearly I was ready, but my computer was not. So anyway, a compound inequality containing the word and is true if both of the inequalities are true statements. So the graph of this inequality is the overlap, or we could say the intersection. So it's where these two graphs would cross over each other. So if we take a look at this, we have been told, first of all, number 1, I see the word and. So I know I've got a compound inequality that contains the word and it's only going to be true if both of the inequalities are true. So you'll notice I've given you 3 different lines that we're going to be graphing on. Here's how we're going to use those 3 lines. First of all, I'm going to look at the first equation, which says, or first inequality, pardon me, says x is less than 2. So I'm going to go ahead and graph what x is less than 2 looks like. So I'm going to put a spot where I see a 2, and then I could obviously keep going. And because it's just less than, that's the open circle. X is less than 2 would look like this. I see the word and it says and when x is greater than or equal to -1. So I'm going to come down here, and -1 is down here, but because it's greater than or equal to, I've got to fill that in, and it says greater than, so it would go this way. Now remember, it's where they overlap or intersect. So where do those two things cross? Well, if I take my handy dandy highlighter, right here is the part they share. So since that is the part they share, on my final graph of this problem, I would put an open circle at 2, a closed or filled in circle at -1, and I would connect them. That is where those 2 inequalities cross over. So that is true only in this particular area is that equality true. But because they cross over, it's true, so I know we're okay. All right, the next one, again, we see the word and. So we're going to treat this, x is greater than -3, so I'm going to come down here and find my -3, open circle, and draw to anything greater than that -3. The next one says x is greater than or equal to 1. So here is a +1. Greater than or equal to means I can have a filled in or a closed circle, and greater than or equal to. Now, this one gets a little more interesting. Where do those 2 overlap? Again, the focus is on the overlap. They overlap with, at this point, everything to the right of that. So since they overlap there, everything to the right of that, then we're going to mark the 1, and our equation is going to be that filled in or that closed up circle and everything to the right of that. That's the part that they share. All right, so now, oftentimes we don't see these inequalities as two separate inequalities with the word "and" in between them. Often we see it looking like this right here. All right, let's try to get this to not move on us. We see it written like this often. What this means is that x is greater than -3, okay, even though it's written like this, remember how we can flip that, and that x is less than 2. All right. Now, would this change if one of these had an equal to symbol under it? Absolutely. If it had x is less than or equal to 2, we would have said less than or equal to 2, which is actually what I think it says on your notes. All right, so then we can go on. A compound inequality containing the word "or" is true if one or both are true. So now I no longer need to have both parts be accurate. It will fit that particular compound inequality if at least one of the parts is true. The graph of this particular inequality is the union of the graphs of the two inequalities. In other words, it needs to belong to at least one of the sets. So we need to belong to at least one of the sets. All right, so if we go ahead and then take a look at this, I'm going to see if I can slide this down a little bit. If you get a little motion sickness, don't watch too closely. All right, so now I have x is less than -2 or x is greater than 1. Okay, so when I graph my answer here, again, we're going to focus on this. So if I go, here is my -2. Doesn't look a lot. There we go. X is less than -2, so I would use my open circle. And I would go to the left of that. For this one, the way I graph that one is I go, okay, here is the +1, and it's greater than or equal to +1, so I fill in my circle and I draw my arrow this way. Now, this is not where they overlap or intersect anymore. Now we're looking at least one of the sets has to be true. So when I graph my final answer, and this is the one we're most interested in, here's how it looks. So we're going to have the open circle at -2, and it's going to go this way. We're going to have the filled in circle at +1, and it's going to go this way. So here's what this tells me. As long as the number I'm choosing is not anything between -2 and 0.99999, it's good. If I pick anything in that in-between spot, this right in here, then it would not work. So what I choose just has to belong either over here or over here. As long as I do that, it works. All right, so we're going to go ahead and look at this next one. So P is less than 1, so I come over here. Here's my 1. P is less than 1, indicates open circle, arrow over. Again, I've got that word "or" there. P is less than or equal to -3. So less than or equal to -3. So here's my -3. It's got the filled in circle and it goes less than. And now it has to belong to at least one of the sets. Well, the first thing I notice is, whoa, they are both crossing over each other. And the one that is the furthest away is this 1 over here. So open circle to the left. That is where it fits one or the other. They just happen to share part of that same line. And now, the moment you've all been waiting for, it's your turn. Please graph the solution sets. If it makes sense to you to think about them each individually, like I showed you, and you've got the three lines, you certainly can do that. If you can graph one and graph the other and then make the decision about where do they cross over, how does that work, that's fine as well. Good luck on this, and we'll talk about your answers tomorrow. Have a great night.